Hey, this is Presh Talwalkar reminding you to mind your decisions. You are given a normal die and a blank die. Label the blank die using the numbers 0 to 6 so that when you roll the two dice, the sum shows each whole number from 1 to 12 with equal chance. You can use a number more than once or not at all. So you could label the faces 1, 2, 3, 4, 4, 5. But you do have to label all 6 faces of the blank die. This was asked as an interview question at Amazon. Before I go any further, I want to share an important point about these probability videos. I received an email from Dr. Gleb Yakubov, who's an assistant professor at the University of Nottingham in the UK. He writes, "Hi, I just wanted to let you know I mentioned your puzzle, what is the distance between two random points in a square, in my recent research paper. I thought it would be good to show how your channel can not only stimulate students, including those in my class, but also stimulate research questions. Thank you so much for letting me know. I know probability is not everyone's favorite subject, but these videos are important, so I'll share probability videos from time to time." So going back to the puzzle, pause if you'd like to give it a try, and when you're ready, keep watching the video to learn how to solve this problem. So how can we solve this problem? We'll get started with an observation. When you roll two 6-sided fair dice, you get 6 times 6, which equals 36 equally likely outcomes. Let's make a little table of this. The standard fair die will have the faces 1 through 6. The mystery die will have 6 unknown faces. We need these 36 sums to be divided into 12 equally likely sums because we need the numbers 1 through 12 to occur with equal chance. So each sum has to appear 36 divided by 12, which equals 3 times. We need 3 entries of 12, 3 entries of 11, and so on, all the way to 3 entries of 1. Now how do we get 3 entries of 12? Well, 6 is the largest number that we can put on the mystery die. So notice the only way we can get a sum of 12 is 6 plus 6. So that means we're going to need 3 faces to be labeled with 6. That's the only way we can get 3 sums of 12. Now by similar logic, how can we get a sum of 1? Well, 0 is the smallest number for the mystery die, and the only way we can get a sum of 1 is if we do 0 plus 1. So we're going to need 3 faces to be labeled as 0. So now we've actually labeled all 6 faces. Do we have a solution? Let's fill in the rest of the sums. The first row goes from 1 to 6, and the next 2 rows will be the same. Then this row will go from 7 to 12, and the next 2 rows will be the same. And look at this table carefully. Each sum from 1 to 12 appears exactly 3 times, and by magic we have found the answer. The mystery die needs to be labeled with 3 faces of 0 and 3 faces of 6. So we kind of lucked into the answer, and that's good for this problem, and it would be great in an interview. But how would you solve this problem in a more systematic way? I want to show you another method. It'll be a lot more complicated, but it's a powerful tool to solve such problems. The method is called probability generating functions. If z is a discrete random variable on the non-negative integers, and pi is the probability that z is equal to I, then we define the probability generating function of z as follows. It'll be the polynomial with terms p sub I multiplied by x to the power of I. So let's create the probability generating function for the fair die. Well, the fair die takes the realizations of 1 through 6, and each is equally likely to occur with a chance of 1 over 6. So what's its probability generating function? What we do is we attach the coefficients of x of I to the probability of I. We can now factor out 1 over 6. So here's the probability generating function of the fair die. We can similarly create the probability generating function of the mystery die, and here's the probability generating function of the sums. So why have we done all this? It seems like we've made the problem more complicated. Well, here's the key property. The generating function of a sum of independent random variables is the product of the individual generating functions. So we have d of x multiplied by m of x is equal to u of x. If we divide both sides by d of x, we can solve that m of x is equal to the ratio of u of x over d of x. So in order to solve for this mystery die, we can take this polynomial division. And I can just hear some students saying, when will we ever need this? Well, it looks like polynomial division could actually help you get a high-paying job. So how do we solve this problem? Let's go through the steps. I'll just give an outline form. We want to divide u of x by d of x. So notice the highest power in u of x is x to the power of 12, and that's multiplied by 1/12. And here we have x to the power of 6 multiplied by 1/6. So to get the highest powers to match, we're going to multiply by 1/2 of x to the power of 6. So when we do that, we're actually going to eliminate all of these terms going from x to the power of 7 to x to the power of 12. So what are we left with? Well, let's expand out u of x. The next highest power will be x to the power of 6. We have 1/12 of x to the power of 6, and here we have 1/6 of x to the power of 6. So we're going to multiply this by 1/2, which is also equal to 1/2 of x times 0. We multiply this out and then we subtract, and we actually cancel out all of these terms. So we end up with no remainder. So that's it. M of x is equal to 1/2 multiplied by x to the power of 0 plus 1/2 multiplied by x to the power of 6. Now the mystery die has 6 faces, so we'll rewrite it as 3/6 times x to the power of 0 plus 3/6 times x to the power of 6. And now we can read off the coefficients to see the mystery die needs to be labeled with 3 faces of 0 and 3 faces of 6. Incredible! I think this is a great interview question because you could solve it with the high-powered tools of probability generating functions, but you could also solve it logically considering how the mystery die needs to be labeled to get the correct sums. Thanks for watching and for making Mind Your Decisions one of the best channels on YouTube. Thanks for watching, and thanks for your support.